To begin with, what is Bitcoin?
1 bit 47.
A lot of people are familiar with Lightning, and Liquid is effectively layer 2.
Bit 129.
What is Taproot?
Sure, and Taproot, that's the first new protocol upgrade since SegWit.
Difficulty adjustments.
How do mnemonic seed words work?
UTXO management.
Hello, ungovernable misfits. I hope you've cooled down from our last Bitesize Bitcoin and are ready for something electrifying, like electricity. There are plenty of heady concepts and analogies to convey the process of mining and proof of work, like the transmutation of energy, storing energy in time, or how Bitcoin is money as stored energy. I'll leave those metaphors to the thinkbois. Here, we'll cover some of the basic concepts, terminology related to electricity to gain a better understanding of the process of mining. Because without electricity, we're left to hashing with pencil and paper. In this iteration of Bitesize Bitcoin, we'll define voltage, current, and power, and how we can solve for them using Jules Law. We will define work, watts and joules, and the first law of thermodynamics. Work is measured in joules. Joules is a force exerted on an object over a distance irrespective of time. Energy is the ability to do work. Power is the rate at which a certain quantity of work can be done over a period. We measure this power in watts, or joules of energy used over a period. If you extend 1 joule of energy over 1 second, you have 1 watt. We speak about these terms in the physical or mechanical. So how does this relate to electricity? Let's first define some electrical terms. Voltage. Voltage is the difference of potential between 2 poles that allow movement of electrons to occur. It's this difference that allows the movement of electrons to happen. It can be compared to water flowing down a slide. The greater the difference between the top of the slide and the bottom, the greater the force at the bottom. In voltage, the greater the difference of potential between poles, the higher the voltage. Current. Current is the movement of electrons, or more accurately, the byproduct of the movement of electrons. Negative electrons are repelled from a negative potential to a positive. The greater this potential, the more powerful the movement. Current is defined in amps, or coulombs of charge flowing per second. You get the trend here. We can't define these concepts without time, revealing another facet of Satoshi's wisdom, referring to Bitcoin in terms of a time chain over and over in his code. Now that we understand voltage and current, we can define power by using Jules' law. Power is equal to voltage times the current that is flowing through that difference of potential. That energy is represented in watts. Alternatively, we can say a watt is equal to the joules per second that are being transferred between a voltage at a certain current. The first law of thermodynamics, also called the conservation of energy can be neither created nor destroyed, it just changes form, states that the total amount of energy in the universe is constant. This means that the energy must end up somewhere, either in its original form or in a different form. This enables us to determine the amount of energy in a system, the amount lost as waste heat, and the efficiency of the system. When we mine Bitcoin, we aren't so much consuming energy as we are changing its state, allowing us to do some work. In mining, we are often, not always, taking mechanical motion, i.e. the rotational energy of a generator, turning that into electrical motion, and harnessing electrical motion into hashing power. We then turn that hashing power into guesses and heat. Now, if you want to be true to the laws of thermodynamics, you place that miner as close as possible to the source of power while harnessing the heat, increasing the efficiency of the mining process. But that's a topic for another discussion. Homework time. I've brought in my daughters to demonstrate Jules' Law. All right, kid number 1. Remind the plebs of Jules' Law.
Joules' law states that power equals voltage times the current passing through a component. This equation works for all electronic components, a resistor, a light bulb, or an ASIC.
If we have an ASIC with a power supply rated to do 1400 joules of work in 1 second, how much current will flow through that machine at a difference of potential of 120 volts?
Power is equal to voltage times current, so in order to solve for a current, we divide 1,400 watts of power by 120 volts. That comes to 11.6 amps.
Now let's run that same machine on 240. Kid number 2?
1,400 watts divided by 240
volts is 5.8 amps.
Should we run that machine by supplying it with a greater difference of potential?
Yes.
By reviewing some basic concepts of physics, we can demonstrate Bitcoin's beautiful simplicity. It doesn't have to be any more complicated to describe what's happening in mining than conveying the concepts of work, over time, and the conservation of energy.
I really hope you found that useful. I've designed Bitesize Bitcoin to break things down. The idea is that you can also share these with friends and family, and they're much more digestible. If you enjoyed that and you are hungry for more, go to ungovernablemisfits.com. I want this to be a home for anyone who wants to learn about Bitcoin and any other open source technologies. It's important to me that you have everything that you need, so I've got articles, the main podcast, a shop, and much more. If you have any questions and want to reach out, I'd be happy to help.